This is the first computer program. It's not made of silicon. It's a chain of hole-punched cards. And it wasn't designed to run a computer. It was designed to weave silk. This mechanism, invented in 1801, is the direct ancestor of the software running on your phone. But how? How do you translate a complex, artistic picture of a flower into a simple series of holes? And more importantly, how does a 5-ton machine of wood and iron read those holes to control thousands of threads at high speed? To understand how this card invented software, we have to reverse engineer the devastatingly complex and human problem it was built to solve. Before the 1800s, if you wanted a complex pattern in your fabric, like a damask or a brocade, you couldn't just print it. You had to weave it directly into the cloth. This required a machine called a draw loom, and it was a nightmare of complexity. To create a pattern, you needed 2 people. First, you had the master weaver, who sat here and operated the main loom, throwing the shuttle back and forth. And second, you had him, the drawboy. His entire job was to sit on top of this massive machine for 12 hours a day and be its human processor. Let's look at the problem. To make a pattern, you have to lift a specific set of the vertical warp threads before the weaver passes the horizontal weft thread through. The drawboy had to follow a pattern chart, line by line, and for every single pass of the shuttle, he had to manually pull a precise combination of cords, sometimes hundreds of them, to lift the correct threads. The results were beautiful, but the process was brutal. It was incredibly slow. A few inches of fabric could take all day, and it was devastatingly prone to error. If the drawboy got tired, if he lost his place, if he pulled one wrong cord, poof, the pattern was ruined. Days of work wasted. The technical problem was clear. How do you replace the drawboy? How do you take that complex, repetitive, error-prone human decision-making and automate it? How do you build a program for a machine to follow? The first spark of an idea came in 1725 from a man named Basile Bouchon. He was watching a player piano, and he saw how a perforated paper roll could tell the machine which notes to play. He thought, what if we used that for threads? He built a prototype, but it was clunky and could only handle a small number of threads. Then his assistant, Jean-Baptiste Falcon, had a breakthrough. He realized a long, clumsy paper roll wasn't the answer. In 1728, he replaced it with a series of stiff, connected punch cards strung together in a loop. This was a huge leap. Now, the program wasn't one giant fragile roll. It was a flexible, durable chain. But it was still manual. It still required an operator to press the cards against the needles for every cycle. It was better, but it wasn't automatic. The next giant leap came from an engineering legend, Jacques de Vaucanson. You might know him as the creator of the digesting duck, one of the most famous and complex automatons ever built. Vaucanson wasn't just a toy maker. He was obsessed with automating human work. In 1745, he designed a fully automated loom. It used a perforated cylinder and a complex ratcheting mechanism. It was brilliant, and it was a complete commercial failure. It was too complex, too expensive, and the silk weavers hated it. They saw it as a threat and drove Vaucanson out of town. The idea of a fully automated loom died for almost 50 years. Then we meet our main character,
Joseph Marie Jacquard. Jacquard wasn't a wealthy academic or a famous toy maker. He was a master weaver. He inherited a workshop and a mountain of debt. He knew the pain of the old system. He had been the drawboy. He spent years failing, struggling, trying to find a better way. His eureka moment wasn't one single new idea. It was the genius of synthesis. He took Falcon's flexible, robust punch card chain and he combined it with Vaucanson's powerful automated mechanism for reading them. He perfected it, simplified it, and made it reliable. This is his invention, the Jacquard head, and it is pure binary genius. So, how does it work? Let's reverse engineer the code.
The mechanism has hundreds of these upright steel needles. Each needle is linked to a hook, and each hook is connected to a single warp thread on the loom below. Now here's the program, the chain of punch cards. With each cycle of the loom, this square cylinder rotates, feeding a new card into place. Then, the cylinder presses that card against the entire set of needles. And right here is the simple if-then statement, the binary logic that changed the world. If there is a hole in the card, the needle passes through it. The hook it controls stays in its default down position. When this rising bar comes up, it catches the hook and lifts the thread. This is a 1 in the code. But if there is no hole in the card, the solid card pushes the needle back. This push moves the hook just enough to get it out of the way. When the rising bar comes up, it misses the hook completely. The thread is not lifted. This is a 0 in the code. Hole, no hole. Lift, don't lift. 1, 0. That's it. That is the entire elegant logic. For every single pass of the shuttle, a new card moves into place, presenting a new line of code. The machine reads the card, sets the entire pattern of thousands of threads instantly, the weaver passes the shuttle, and the cycle repeats. The drawboy was gone. The human processor had been replaced. Jacquard had done it. He hadn't just automated a task. He had found a way to store a complex physical idea, the picture of a flower, in a physical, machine-readable format. He had invented programmable abstraction.
Jacquard's invention was an immediate, terrifying success. By 1812, there were over 11,000 Jacquard looms operating in France. But this new power had a profound and immediate consequence. The weavers, the Canuts of Lyon, saw their entire livelihood, their skilled identity being erased by a machine that could do their job faster and more perfectly. They rioted, they smashed the looms. Jacquard himself was attacked and nearly thrown into the river. This was the birth of a fear we are still grappling with today, the fear of automation. The fear of being made obsolete by a machine that can read a program. But the idea, the mental model of a programmable machine, was out of the bottle, and it found its way to a brilliant, famously grumpy English mathematician, Charles Babbage. Babbage was trying to build this, the analytical engine, a massive, steam-powered mechanical computer. But he had a huge problem. How do you feed instructions and data into a thinking machine? The answer, he realized, was already weaving silk in France. Babbage directly adopted Jacquard's punch cards as the input-output system for his engine. The program for the world's first general-purpose computer was a stack of cards borrowed from a loom. The echo only gets louder. Decades later, in the 1880s, the U.S. Census was a disaster. It took 8 full years to manually count the 1880 census. The data was obsolete before it was even published. They needed a faster way. An engineer named Herman Hollerith stepped in. His solution? He built a tabulating machine that used, you guessed it, punch cards. It used the exact same hole, no-hole logic as Jacquard's loom, but instead of lifting a thread, Hollerith's machine completed an electrical circuit which moved a mechanical counter. The machine was a triumph. It saved the census, and the company Hollerith founded to sell this technology was called the Tabulating Machine Company. You and I know it as IBM. This is the legacy. This is the mental model that Jacquard gave us. Programmable abstraction. The next time you open an app, launch a game, or send an email, what you are really doing is running a program, a set of stored instructions abstracted from a complex idea into simple binary logic. It's the very same idea that a 19th century weaver used to store the image of a flower, not in his mind, but in a series of holes. The Jacquard loom didn't just weave silk. It taught us how to think like a machine.